seen that before and whatnot. Okay, can we get 40 likes? I think Seaman is liking and then unliking so that the numbers of the likes are changing. Thank you, Seaman, so much for all your engagement. And thank you for the super chats as well if somebody wants to do that. This is true down to the last detail. All of the matter particles and their antimatter partners as well have spin equal to that of the electron. So all of the matter particles, including the quarks, have spin equal to that of the electron. So same spin as the electron, okay? In the language of the trade, physicists say that matter particles all have spin 1/2. So this is what we call the spin of an electron or the other matter, like or quarks as well. And this is called spin 1/2, where the value 1/2 is roughly speaking a quantum mechanical measure of how quickly the particles rotate. Moreover, physicists have shown that the non-gravitational force carriers, these are photons, so non-gravitational force carriers would of course be the other forces other than gravity. So now what are those other forces once again? Electromagnetism, strong nuclear force, and weak nuclear force. So those force carriers are, again, photons, weak gauge bosons, and gluons. Also possess an intrinsic spinning characteristic that turns out to be twice that of the matter particles, and they all have spin 1. So the spin or the intrinsic spin property of the matter particles is different than that of the force or the gauge particles, the force carrier particles. Matter particles have spin 1/2, what we call spin 1/2, which is a way to describe the spin of the matter particles, such as that of the electron, and force particles have a different spin, which is spin 1, okay? Feeling quirky, hello. This is where I get to say how beautiful you look tonight. Thank you. What about gravity? Well, even before even before string theory, physicists were able to determine what spin the hypothesized graviton must have to be the transmitter of the gravitational force. So there are things. When I hear her say quark, I remember the time she had mead. You mean the honey wine? Oh yeah. Oh yeah. One of these nights I will go back and get some of that again. Thank you for the hearts. Thank you so much. It's back. It's at that Ethiopian restaurant. Yeah. So because of knowing what we expect gravitation to be like, and because of knowing certain other information, we kind of know already, even without really finding the graviton, which would be the force particle for the gravitation force, that its spin has to be spin 2. So the answer is twice the spin of the photons, weak gauge bosons, and gluons, and that would be spin 2. So it's kind of like, what do you mean? It's kind of, it's kind of like, it's kind of like the spin when it's known about certain things. You can start to calculate it for something that you might not even know so much about, but you just know what spin it would have to have. In the context of string theory, spin, just like mass and force charges, is associated with the pattern of vibration that a string executes. So now, coming to string theory. Now remember, superstring theory tries to be a candidate for the theory of everything, which means that it has to explain quantum mechanics as well. It has to subsume both general relativity as well as quantum mechanics and particle physics and the properties of quantum that we expect to get out, right? So something like spin cannot be something that it ignores, for example. It would have to explain it, right? So the way, like, even though spin is a quantum property, we kind of get it from quantum. String theory also has to kind of give us something in terms of spin. Okay, so let's see. In the context of